Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one idea lost more marks than any other on last year's higher papers. Students treated Surds like a memory test instead of a tiny toolbox. Sound familiar? Most lose marks through small slips, missed factors, sign errors, or converting to decimals too soon. Stay with me for the one routine that makes those marks easy to claim. The concept. First, what is a surd? A surd is an exact square root you leave in root form, like root 2 or root 18. We keep answers exact because examiners want exactness unless the question asks for a decimal. Why? Exact answers show understanding and earn the full A marks. Here's the reliable routine. Factor squares, simplify the root, combine like surds. I'll show you why each step works, not just what to do. Step 1. Factor perfect squares from under the root. Example, root 72. You spot that 72 equals 36 times 2, and root 36 is 6, so root 72 equals 6 root 2. Why this works? Square roots reverse squaring. Pulling out root 36 gives you an integer factor outside the root, reducing the surd to its simplest irreducible part. That makes later algebra cleaner. Step 2. Simplify systematically. Take root 72 minus 2 root 8 plus 3 root 2. Work each term. Root 72 becomes 6 root 2. Root 8 is root of 4 times 2 equals 2 root 2, so 2 root 8 is 4 root 2. Now replace 6 root 2 minus 4 root 2 plus 3 root 2. Combine like surds, 6 minus 4 cos 3 root 2 equals 5 root 2. Short and clean. The key is only combine terms with exactly the same root. Root 2 only with root 2. Common trap. Students try to combine root 18 with root 2 directly. Don't do that. First simplify. Root 18 equals root 9 times 2 equals 3 root 2. Once both are in the form k root 2, you can add or subtract the coefficients. That's why factoring perfect squares first is not optional. It's the rule that keeps your algebra valid.
Next idea, rationalizing denominators. If you have a denominator with a surd, like 4 over root 3 plus 1, the exam usually wants the denominator rationalized. No surds left in the bottom. The reliable trick is to multiply top and bottom by the conjugate. If the denominator is a plus b root c, use a minus b root c. This creates a difference of squares in the denominator, which removes the root. It's mechanical, but there's a why. A plus b times a minus b equals a squared minus b squared, and when b contains a root, b squared removes it. Exam technique. What do examiners want? For a 3-mark surd question, you'll usually see M1 for a correct simplification step, M1 for correct algebra or rationalizing method, and A1 for the final exact answer. That means even if you can't finish, the examiner can give method marks for clear intermediate steps. Write things down. Write it down, don't just think it. Specifics to show on your script. When simplifying, write the factorization under the root. For example, root 72 equals root 36 times 2 equals 6 root 2. That line wins M1. When rationalizing, show the multiplier and the conjugate. Multiply numerator and denominator by root 3 minus 1. Show the denominator becomes a difference of squares. Examiners love this one because it proves your method. Common examiner pitfalls to avoid. 1. Forgetting to expand the numerator fully after multiplying by the conjugate. 2. Dropping a negative sign when distributing. And 3. Converting to decimals too early. If a question wants an exact answer, decimals will lose you the A mark. Keep exact until the end. Quick win. A 20-second rationalizing routine. See the denominator, pick its conjugate, multiply top and bottom, use difference of squares, cancel any common integer factors.
Then do a 10-second sanity check. Estimate both original and final expressions with a calculator. They should match to 2 decimal places. That check catches sign errors and missed factors almost every time. Quick win in one line. Multiply by the conjugate, simplify the denominator to an integer, then cancel.
Now let's do a worked practice question at exam pace. I'll read it, pause so you can try, then we'll walk through it. Question. Simplify square root 72 minus 2 square root of 8 plus 3 square root of 2. Then rationalise the denominator of 4 over the square root of 3 plus 1, giving your final answer in the form a plus b square root of 3. Ready? Take 15 seconds to try the first part now.
Part 2. Rationalise 4 over root 3 plus 1. Multiply top and bottom by the conjugate, root 3 minus 1. So you get 4, root 3 minus 1, over root 3 plus 1, root 3 minus 1. Denominator is a difference of squares. 3 minus 1 equals 2. So the denominator becomes 2. The numerator is 4 root 3 minus 4. Divide both terms by 2 to simplify. 4 root 3 over 2 minus 4 over 2 equals 2 root 3 minus 2. So the final answer in a plus b root 3 form is minus 2 plus 2 root 3, or better written, 2 root 3 minus 2. That's the exact form the examiner wants. So, marking commentary, M1 for multiplying by the conjugate, M1 for recognising denominator becomes 2, and A1 for the final simplified exact answer, 2 root 3 minus 2. If you had left a factor of 2 common in numerator and not divided through, you'd lose an accuracy mark on presentation, so tidy simplification pays.
Sanity check. Estimate root 3 approximately 1.732. So 4 over 1.732 plus 1, approximately 4 over 2.732, approximately 1.464. Our final 2, root 3 minus 2, is 2 times 1.732 minus 2, approximately 3.464 minus 2 equals 1.464. Matches. That quick decimal check takes 10 seconds and catches sign or factor errors. Don't skip the check. Don't skip the check. Practice prompt. Pause now and try 2 quick variations. Simplify square root 50 plus 3 root 2 and rationalise 5 over square root 2 minus 1. Use the same routine. If you want worked solutions, there's a downloadable pack in the show notes. Practicing this routine until it becomes automatic saves time and prevents silly errors under exam pressure. That's your quick win for today. Multiply by the conjugate, simplify, and do a 2-second decimal check. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.